Hi, today we're talking about 6.3, multivariable linear systems. Essentially, this is when we have three or more systems, or three or more equations in a system with three or more variables, and we're going to utilize the matrix function on our calculator and do our RREF, our row reduced echelon form, to help us solve it. So RREF essentially does the elimination method for us. So if I had this system of equations here and I wanted to do my elimination method, I would take that second equation, 3x minus y, x minus y equals 0, and multiply everything through by 3, and that would give me negative 3x plus 3y equals 0. And then what happens is now when I add my two equations together, the 3x's cancel each other, they eliminate each other, and I get down to y equals negative 1, which I can plug back into any of the equations up above and get my x equals negative 1, and I get my system, or my solution to my system. Our matrix will do the same thing for us. So we have to create what we call the coefficient matrix, where we take all the coefficients and we put them in our matrix. And we want to make sure that before we do that, we have the system set up so that all of the equations look like this, where they have the variables in the same order. So we go x, y, and then equals that constant. And so when it's set up like this, it's really easy to go over to our coefficient matrix. So that first column here, that's going to be our x coefficients. That's the 3 and then the 1 in front of our x here. Our second column is going to be the y column. Those are our y coefficients, the negative 2 and the negative 1. And then that last column there, this column is going to be our constants column. And this is the column we're eventually going to pull our answers from. And so what the row reduced echelon form, what your calculator does when you ask it to do row reduced echelon form, is it does the elimination method. It creates that second row, changes that second row to be negative 3, positive 3, 0, by multiplying everything through by a negative 3. And then we get down to this last equation here, this last matrix, and we have what's called our identity matrix on the left, the two columns on the left. And we want our matrix to have this form where we have these ones down the diagonal and everything else is 0. And so if this was a 3 by 3 or a 3 by 4 matrix, we would have 3 ones going down the diagonal and everything else is 0. And then we have that constants column on the right hand side, and that's where we're going to pull our answers from. So we get that our answers are negative 1 and 1, and that's because this first negative 1 matches with the 1 in the x column. So that 1 in that first spot is an x column 1. So this is saying that x equals negative 1. And then the 1 in the second column, in that y's column, matches with the negative 1 in the constants column, and that gives me that y equals negative 1. That's why I want those other zeros, to get rid of the x's and y's in those. But that's how I get my two answers. That x is negative 1 and y is negative 1. So a two-system equation, we usually wouldn't use a matrix to help us solve that. We can do a substitution, we can do elimination. Goes a little bit faster than typing everything into our calculator. But when we have something with our three systems, so here's the same thing, and that last column contains the answers. When we have something with three equations, three variables and three equations like we have here, to solve this by hand is possible, but it takes a really long time. And so it's easier, significantly easier, if we use our matrix on our calculator. So first thing I want to do is make sure it's set up correctly, that I go x, y, z equals some constant. And I do for the most part, except I really don't in this second line here. In that second line, that second equation, I am missing my z variable. And so all that tells me is that z variable has a coefficient of 0. So if I really wanted to, I could rewrite this as negative x plus 3y plus 0z equals negative 4. And then that becomes a lot more obvious that that coefficient on z is 0. But what we're going to do is we are going to go to our matrix. We're going to go to the matrix on our calculator. So I'm going to pull that up for us. And on your matrix, on your calculator over here, on the left-hand side, we have where it goes the second button, alpha, and then math, and then underneath math we have the x to the negative 1, and right above it in blue you can see where it says matrix. So I do want to hit second and then that button, second and then that button, and it's going to take me to this whole new screen, and I've got these options for all these matrices, A through I, and it keeps going. And what I want to do is I want to arrow over to edit, and I can pick any of the ones. So I've already got ones in A and B, and I can go through and I can re-edit those. I can edit over what I have in there, or I can go create a new one. It is truly up to you. I'm just going to edit over A. And I do want it to be a 3x4 matrix, which is what I have in here. But I do want to make sure the dimensions are 3x4 because I have 3 equations. So that first value, that 3, is how many rows, how many equations we have. And then the 4, the second value is how many columns, and we're going to have 1 column for each variable. And then we also have that constants column. So these aren't going to be the same. You're usually going to have 1 more column than you do rows. But we're going to take our matrix here and we're going to put in all of those coefficients from our system. So go ahead and do that on your calculator. I'm going to do that on here, and then we'll come back together and we'll check, we'll make sure we match. So mine actually already matched. I had kept it in here from before when I had done it during class. But the key thing is you do want to make sure that you have that 0 in there for that second equation for the z variable, that z coefficient. We don't have a z in that second equation. So I do want to make sure that there is a 0 in there. But after I enter all of my variables, all of my coefficients into this matrix here, I do need to quit. So I'm going to hit second and then mode. That's going to quit and get me back to that main screen on our calculator. And I need to go back into the matrix category, my matrix screen. And I do have to quit because otherwise I'm still in the editing mode. So I do need to make sure I quit and then go back into that matrix screen. And I'm going to arrow over to this math option. And I've got a lot of options, and I'm going to just scroll down until I see RREF, the RREF, or the row reduced echelon form. So there is an REF, but I want the RREF. That's going to completely solve it for me. So I'm going to select that, and then I'm going to go back again into my matrix, and I had done this in my A matrix, so I want to make sure I keep track of which one I put this in. I put it in my A matrix, and I can click enter, and it will do all of that work for me, and I get my solution. I get my 1, -1, and 2. So if I go back to this PowerPoint here, we get, those are my solutions. Those are my answers, my x, my y, and my z variables. You can do this for any system that we have as long as they are all linear, so we don't have any exponents on them. But I can do this over here. So we're going to try this. I want you to try this one on your own. You want to make sure there are no decimals in your answer. I'll explain how to do that in a minute, but go ahead, take a minute, try it, put it into your matrix, do the RREF, and see what we get. So this is what your matrix should look like in your calculator in that editing mode. And then when I go back through and I want to do that RREF again, I'm going to go into my matrix category and go over to math, and I'm going to scroll until I get to that RREF, row reduced echelon form option. Oops, too far. And I do this and I choose that I want to do it on my matrix. I did it in matrix B this time. You may have gone back and overwritten your matrix A. That's absolutely fine. But this is what I get this time, and there's the problem. I have all of these decimals, and I don't want those decimals. I want this to be in fractions. So your calculator will do that for you. You have this math button off on the left, the third one down on the left-hand side. And if I click on that, I get this screen, and my very first option is this arrow to frac. And if I select that, if I click enter, it'll take my answer, the matrix from right up above, and it'll convert it all into fraction form, and I get my solution matrix. I get this here. So we would get that our x is 7/9, our y is 5/6, and our z is -19 over 9. So we can do it again with this matrix. So I want you to try this one. Now this one's going to give us something that's a little different. We'll talk about that, but go ahead and put this into your matrix. Remember, you have to have those zeros in for those missing variables. So in that first equation, we're missing a z. So we'll put a 0 in the z spot. Our second equation is missing an x, and our third equation is missing a y. So if you really want to, you can rewrite these as x minus y plus 0z equals 1, 0x plus y plus z equals 1, and then x plus 0y plus z equals 2, if that helps remind you to put in those zeros there. So go ahead and do that, and we'll join back up in just. So if you do this in your calculator, you should get this matrix as your answer, and you'll notice that this is different. The last row there is a row full of all zeros. So that would, if I were to convert that back into an equation, would tell me that 0x plus 0y plus 0z equals 0. But if I have 0x, 0y, and 0z on the left, then that's just a 0 is equal to 0. And this is a true statement. 0 is equal to 0 all the time. No matter what other my variables might be, whatever my x, my y, my z are, 0 is equal to 0. So if you end up with a function or with a matrix that gives you back an entire row of zeros all the way to the very end, then that means that this is going to be an infinite number of solutions. There is not just one point where they intersect, but there is an infinite number of points where these three equations intersect with each other. So we say we have an infinite number of solutions for this system. In our fourth one, I want you to do this one again. Put it in your matrix, in your calculator, and again, you're going to get an interesting looking matrix. Take a minute, pause the video, try and put it in and see what you get. Now you should get this matrix here after you do that whole RREF on your calculator. And notice this does look a little different again. If I look at that last line, I have almost an entire row of zeros, but not quite. All of my coefficient columns have a 0 in them. So this one would create the new equation where I'd have 0x plus 0y plus 0z now equals 1. But again, the same thing. If you have 0x, 0y, and 0z, that entire left side is just 0. But now I'm trying to say that equals 1, and that's an issue because 0 does not equal 1. This right here is a false statement. And so if I end up with this, where I have a false statement, then I would say I have no solution. There is no x, y, or z value that would make that last line, that last equation, 0 equals 1 true. So we're going to do a couple application problems. I'm not going to do all of them, but we'll do a couple to get you started. Again, we're going to do the setup. We're going to set it up as a 3 equations or 2 equations or 2 or 3 equations. And then we're going to use our matrix on our calculator to help us solve them. So in number 5 here, we have this inheritance. $12,000 is invested in 3 different funds. So that's an idea that I'm going to have 3 different variables, one for each of those different funds. There's a money market account, pays 3%. Municipal bond pays 4%, and a mutual funds that pay 7%. And I've got these other facts about them. The amount invested in the mutual funds was $4,000 more than the amount invested in the municipal bonds. And then the total interest was $670. So I want to know how much was invested in each fund. So I'm going to start by writing what my variables represent. And I have 3 funds. So I'm going to have 3 variables, one for each fund. So I can say x is equal to the amount in the money market, which is the 3%. So every time I see money market, I could replace that with X. Y is going to be the amount in our municipal bonds, which is the 4%. And then I'm going to have Z be the amount of money that was in the mutual funds, or 7%. So now when I read through the question and I see the amount invested in mutual funds, I can go and I can replace that with a Z. This says the amount invested in mutual funds. That's saying Z was 4,000 more than the amount invested in municipal bonds, or Y. So Z is 4,000 more than Y. So if I have that new sentence, Z is 4,000 more than Y, I need to convert that into an equation. Anytime you see the word is, that always means equals. So I can say Z equals, and then 4,000 more than Y means I'm going to add 4,000 and Y. So I get Z equals 4,000 plus Y. Now, I actually skipped over the very first fact that we have. The very first fact that we have was that the inheritance was $12,000. So my $12,000 had gotten split up into X, Y, and Z. So that does mean that if I take my X, my Y, and my Z and I put them all together, add them all together, I do need to get that $12,000 back. So that's the very first fact. And then the second fact was the 4,000 more. The Z is 4,000 more than Y. Our last one has to do with the interest rate. We talked about this a little bit yesterday. When we do our interest rate, the total interest rate is $670. That's the interest on X plus the interest on Y plus the interest on Z. So I get 0.03X plus 0.04Y plus 0.07Z. And that all together has to equal that 670. And there are my three equations. Three variables. I need at least three equations. And once I get my three equations, I am good. I'm going to use my matrix and my calculator to help me solve this. But before I do that, I do want to make sure that this is in that correct form where we go X, Y, Z equals a constant. And on my second two equations that I have here, I'm in that form already. But it's that first equation. This equation here that's not quite in that form. So I do want to rewrite that. So I'm going to rewrite that down below. And what I'm going to do is I'm going to subtract Y. And I still have 0x. I don't have an x, so I'm going to put the 0 in there. But then I'm going to subtract Y on both sides. And I get negative Y plus Z equals 4,000. And now I have my three equations written in the same form, X, Y, Z equals a constant, and I can go straight to that coefficient matrix in your calculator. So go ahead and do that. I'll give you a second to do that. Pause the video, and come back and check your answer. So you should get from your matrix that X is $2,000, Y is $3,000, and Z is $7,000. So there's on the back of your note sheet, there is a whole set of problems that we're going to do in class together, and I'm going to post the answers to those as a PDF on Schoology, so you can check those. If you have any questions on those, we're going to work on them in class with groups. You can ask me. We can go over it together. But go ahead, try those, work them. Remember, you're going to set up a system. Either 2 or 3 variables, and then if it's 2 variables, you could solve that by hand. 3 variables, definitely use the matrix function on your calculator.